Hey guys, welcome back to the channel. Sorry it's been a little while since I've been making videos. I was finishing school and then getting settled at my full-time job and the new responsibilities. I'm back, hoping to make a lot more videos a lot more frequently. So today I'm going to start off by making a quick little, hopefully 10 to 12 minute tutorial on communicating between your computer in C++ and Arduino over serial, or really any microcontroller, but specifically for Arduino. So let's get started. Let me show you what we're going to be building. If I go to the terminal and I make sure I make the application real quick, yep, it's already made, and I run it, it's going to send a signal to the Arduino, and it's going to turn on the light, which you're going to see there. And now you can also do it to receive information from the Arduino. So if I go change the code, which I'll go over in a second here, if I go change it, that, and then go to the Arduino and actually change it to send that out. Oh, and that's all it should do. Actually, that should be fine if I leave it that way. And then we're going to make it one more time and run it. Now we'll actually see that it's going to get a response from the Arduino and it's going to say hello. That's the hello that the Arduino sent. So without further ado, let's get into it. Alright, first thing we're going to do is go look at the code. So the code we're going to be using is heavily reliant on a library called Woodward Serial, and I'm probably butchering the first part of that. It's a very common library for serial communication between microcontrollers and C++. Really just C++ in general over serial. So we're going to include that, and then what we're going to do is we're going to set up the port and just write to it. It's pretty much straightforward what you're seeing here. We've got 33 lines of code, not including spaces, and the good last 4 of those are just for reading for the one example. So first thing we want to do is we want to actually go get the library. So we're going to open up here to GitHub, and this is going to be linked in the description. Shout out to this guy, or really the team of contributors here. It's an amazing library. I love it, and specifically it works really well with CMake, which is fantastic. So the first thing we're going to do is actually clone this. So if we go ahead and grab it all, I'm going to make a new folder, and we're going to actually, let's do this, new folder, let's go here, just because I want to show you guys the example here, what to do. Okay, so this is the actual repo that it has. You've got your CMake list, the docs, examples include, source, and test. So really, we're going to take the approach where what you could do is you could install this system-wide and then just import it like you would any other system-wide library to your program. I'm actually going to do it where it's actually packaged with it. So I'm going to grab the include in the source files. So if you go into the include, you got the serial folder. If you go into there, you'll see you've got the impl, serial.h, and the v8 student. Now if we go back 1 or 2 actually and go into the source, you're also going to see the source serial.cc and the impl. The impl carries its own specific files for different systems. Specifically, we're just going to use the unix.cc and the unix.h, but you can also have one for Windows. So if I go back and go actually to the code that we've got, and all this code's going to be on GitHub by the end of it. If we go into there, if I can type, what you'll see is that I've actually included it in the I made a third-party folder, include serial.h. So all I did, if I drag this over and go dual side with this, I'm going to go into the include, and you'll see I just included the include folder, of serial with its core stuff into a third-party folder. So over here, what we do is we're going to make a third-party folder and drop in the include files, exactly how you see them with the serial. So you can say I've got serial in there, so if I go on serial, I've got IMPL, serial.h, and v8 student. Just drop those into there. And then you're also going to make a source folder and, surprise, surprise, do the exact same thing with the source folder. Just drag and drop the entire source folder into that third-party folder. Cool. So now that you've done that, you're going to be able to have access to the library. We're going to have to point CMakeList to it, but that's fine. I'll show you how to do that in a second here. Okay, so now that we've included it into our directory, we actually need to pull it into the code. So the way to do that is just through include third-party include serial.h. I also include library IOStream for just standard printing, and thread for some sleeping. There's some timing issues between the serial library and the Arduino and making sure that they catch what each other's saying. So some thread sleeps are going to help with that. So the next thing we're going to do is actually make a serial object from the library. And you can look in depth of this, of what it does. If you go to the serial.cc, you can see all the different functions it can have. If you go to the include, go to serial.h, you can see all the different pieces this library carries with it. It's really straightforward. If you actually are curious, wanting to do more with it, or figure out what the defaults are, going to this header file, it's written very well and it's very well documented, which is awesome. You don't see that very often. So we make an object. We're going to set it to the port. So how do we find that port? Well, when you plug Arduino in, as many of you know if you've had to deal with this before, what you're going to see is if you go to Tools, you're going to have your board. You can select your board. I'm using an Arduino Uno, and it'll actually give you a port. So if I unplug real quick, this should go away if I open Tools again. Yeah, it lost the port. It has no idea what port Arduino is actually connected on. Here it's actually not seeing it at all because I'm unplugged. If I plug it back in, what you're going to see if I open up Tools again is it auto-connected, but it's also going to show you the port. And this port number is dev tty acm0. And that's how all of these serial connections are. If you actually go to your terminal, and we're going to do it in this guy, and you go to cd dev, you're going to see a whole lot of files here. But if you want to specifically look for dev tty, what you would do is you do cd, or rather lstty, do the wildcard, and you're going to see only just the TTYs. These are going to be your serial communication ones. Specifically, what you're looking for is you're either going to have something like this, the ACM0, or what you might have if I plug in another Arduino that I have real quick. Give me 1 second. You're actually going to see if I refresh TTY USB 0. And that's a pretty standard port that you're going to operate on for a lot of this serial communication stuff. Specifically for work, I know that's the port we have for one of our microcontrollers. My boards specifically that I have here, almost all of them are on that one. And then the standard Arduinos are actually usually the ACM zeros, at least on Linux. This is very Linux specific. So if I close that, what we've got there is then if we go back to the code, we set that port up, and then we set the baud rate. So the baud rate is just like an Arduino. When you do the serial communications where you begin it, you set the baud rate. One of the standard ones you might see here is 9600, and that's the default for the Woodruff serial library. I set it specifically to 1920 just because I wanted to get a little extra speed. I wanted to see the timing behavior of that. And right here is where you match those up. And then you do just a little serial timeout, simple timeout. What that says is after 3000 milliseconds of basically not getting an ACK or not getting communication back from either end, it's going to consider it a timeout. And it's going to say, I simply couldn't communicate with the edge device that you were trying to communicate with. Obviously 3000 milliseconds equaling 3 seconds. So that's fairly long for time to not be communicating at. You probably drop that down to about a second. Then what we're going to do is we're actually going to open up the port. So you need to initialize the port by opening it up before you can actually communicate over it. So we're going to do a simple check. We're going to call isOpen. What that's going to do is actually, right here, it's going to get opened up. And then here it's going to check, was that opened successfully? So if it was, we're just going to print to the console, okay, port was opened successfully. If not, we're going to say port failed to open. And actually what we should do here is we should actually exit on this guy. Actually, that is going to be a function call. Or we're going to exit 1. I'm being silly. Okay, then what we do is we just flush the serial. So flushing the serial just clears anything that might be in the buffer. Serial can often operate in a kind of buffered status where it's going to send it kind of all in packets together. What you want here is to actually have it flushed per read or per write so that you don't get data from the previous block. If you know that it's coming in intervals or you know a key character For the Arduino, when we look at that code, it's actually looking for a new line character to call it that block done and then reset and flush. Here we're just saying flush every time you're going to start writing, basically on startup in case there's anything from the previous run. Then if I uncomment all of this and I comment out the read section, because this is just an example for reading, what we actually are going to have here is I'm just going to send the string hi. And specifically the Arduino code that we're using is looking for the new line character, like I said. So you need to manually include the /n because by default the C++ string object does not carry with it the new line character. Then what I do here, we're going to ignore the for loop for a second. Let's jump to line 22. We're going to call the serial library function write. And we're going to pass it in a sample string, not by reference or anything, just straight up full ownership, full copy. And it's going to return the number of bytes that were written. So here, every byte is a single character. So H, I, and then new line itself is a character. So this should say 3. I believe we run the program as is. If we go to the build and make it again, because I just changed the code, and run it. Yep, bytes sent equals 3. And it's actually going to send it a couple times because of the code. And then it's going to respond. It's going to sleep for 2 seconds, come back up and write it again. So the reason I'm writing 3 times is because of the timing issue I discussed earlier with the Arduino and the C++ communication. What usually happens is this first write actually seems to get lost. So by the time it goes through, it's actually not getting received fully on the Arduino. Something's going on where it's actually not registering as a new line at the end and a completion of the write. That usually is only on the first write. I was testing this out, and after you do the initial write, any other writes, whether there's a huge time delay in between them or not, are going to come through just fine. So it's just the initialization of that serial. So that's something to keep in mind. If any of you guys know more or how to fix that, please leave it in the comments, and I'll make a follow-up about, hey, I was being silly, or yep, that's just how it is. One of those two. So we sleep for 2 seconds, and then on the second one, it'll actually write through totally, and on the third one as well. And you'll see the end behavior, which is the LED lighting up on the Arduino. If we come down here, we sleep, and that's it. So that's the entire write section. So let's jump over to the Arduino code. If we go to the Arduino code, this is actually straight up an example that's been slightly modified. So if you were going to go to File and Examples, super straightforward. You've got communication right here. Arduino's done a great job of giving you a lot of starting code. And what you're actually looking for is the serial event, I do believe. Open that guy up. And here's the core of the code. What it does at default with the example is say, okay, I've got an empty string that I'm going to start adding characters to. I'm going to have a flag that says, is the string complete? It's going to default to false because obviously it's got no data in the beginning. Then we do the initial setup, and we're going to set the serial port open to 9600 baud rate. Obviously for ours, we need to change that to match whatever we had in the code. For us, 1920 right here. So if I do that, and we'll actually just do it on this guy right here. We'll go 1920. Oops. Or 19200 rather. And then right here, it's going to say, okay, because this is a string object, I want to tell it how big the string is going to be. Rather, in kind of C++ land, this would be like a string array, or what you're going to store, and you need to know how many bytes you want to keep. So here we're going to be able to store 200 or 200 characters. In the void loop, we have a simple check that says if the string is complete, so if that flag was set to true, then we're going to print out the string that we received. We're going to clear it by just setting it back to an empty string, and we're going to set the flag to false. So every time when the loop comes through, it's going to come and check that. If it enters it, obviously it's going to execute those 3 things. Otherwise, it's going to run, hit the if, jump out, wait to hit again. Now here's the cool part about Arduino, and this is some of the stuff that specifically was new to me when I came back to Arduino after about a couple years of not using it, which was really cool. They built in the serial event function. The serial event function triggers, and you can read it here actually, but it triggers every time new data is going to come through on the RX pin. So the RX on serial, there's TX and RX, transmission and receive, and they're hooked up cross to each other of the communication. So the Arduino's RX is going to hook up to the computer's TX, computer's TX to the Arduino's RX, transmission and receive. So what's going to happen is every time a new piece of data comes over that wire, this function is going to get called. It's basically a callback that gets triggered on. You could think of it like an interrupt if that's kind of where you come from, but it's not like a software interrupt, which is pretty cool. You don't have to manually add any of that yourself. Basically, it's going to say while there's serial available, so while there's something on the serial line that you can read out, grab it as a char. So specifically it designates as a char, and it says cast it as a char right here, the serial read. So the char is going to get converted over from whatever you send as a byte to character. So byte and char have the same unit size. They should be 8 bits or 1 byte. So doing it character at a time is no problem at all to be sending it over. Then you do the input string, you add it. So because this is just a char, you're going to append it onto the string. You're not going to take the whole string at once. You're going to actually take pieces of it, which is where I was coming back to with the flushing. You want to flush that buffer, otherwise you could just have a piece of it. If it didn't read correctly, you might be stuck halfway between sending the word hello. So it might be stuck at the L, and you haven't actually written the rest of it, and you start appending the new string back onto that. So you might have HELH again, which you wouldn't want if you're not flushing, or you're not handling that incomplete string detection correctly. Then you append it, and then you basically say, okay, was that char a new line? And specifically, you can see it's a char for the new line with a single quotes, that's indicating char, or rather character, and then you've got the new line. If so, set that flag to complete. So what that happens, this runs in between the void loop. So on the next loop, if that's done, it's going to come here, oh, that was complete, print it out, set it, empty it, and then set this back to false, so next time it doesn't execute this loop. And that just runs infinitely, and it's going to be consistently checking. The one thing I did add here is I actually added a little LED onto pin 12. So what we're going to do here is we're going to go, okay, we're going to say pin mode, and we're just going to directly call it out, and we're going to say it's an output, and then we're going to say right here, if it's true, we're going to say digital write 12 high, and then we're going to do delay of 1 second, if I could type, and then we're going to turn it off. Jeepers. Okay, so what that's going to do is it's obviously just going to blink the file, or blink the LED on completion of the string. One thing to note here, though, is this delay is taking up a second at a time. And because the Arduino isn't multi-core or threaded or anything like that, that delay will actually potentially hold up this serial read. So as it says here, you can say it runs in between each loop. So adding a delay can delay the response. Basically, what could happen is you might end up with bytes being ready on serial, accumulating, and you're not reading them fast enough. So they could accumulate and almost buffer there. So it's something to be careful about, and you need to maybe do some more clever stuff if you need to have very fast response time on a call from C++. Specifically for this, we don't. We're just doing a basic example to show you how to start communicating information across. I know that's sometimes a little tricky. Specifically, if you're going to do something like the Raspberry Pi over to the Arduino, this is going to be really useful. So anyways, if we just go ahead and make sure we've got the correct port, yep, right there, and we just go ahead and hit Control-U, we're going to upload it, and apparently I can't spell. Now we're going to upload it. Oh, man. I really can't spell. Okay, so it's done uploading, and now it's going to be on the Arduino. So if I bring the Arduino into frame here, go ahead and run the code over here, you're going to see that it's going to send the first one, send the second one, and then send the third one. And it blinked twice. First one got thrown out, and the second two made it through just fine. Okay, so we've looked at the writing of serial. Now let's look at receiving from the Arduino to your system, whether it's your computer or your Raspberry Pi. To do that, it's even simpler. Let's comment out all this write code, and let's uncomment the read code. So the first thing I have is a little sleep for 2 seconds. That's just to make sure that the Arduino is initialized and that the communication is stable and ready. Basically, this won't be needed in a larger program where maybe your initialization takes longer and it's got enough time to get things stable on the microcontroller side. but because this is just a quick readout immediately, we're going to put that delay in there, just make sure everything's all good. We're going to flush the input, just like we flush output for sending messages, we want to flush input for receiving them, so we don't have any buffer data that isn't set at the end line or the full string that you've sent over. We don't want to get caught halfway through a word when we're reading. So then I'm going to call the serial read function. And the mySerial, specifically the one on our object, read function, takes in one parameter and takes the number of bytes that you're expecting to read. So I'm going to tell it 6 bytes. I'm sending over the string hello, but it also is sending over the new line character. So I'm going to say, okay, you've got 6 bytes to read. After that, that's the response. Store it in a string, and then we're just going to print it out to console. So if I save this, I go over to our terminal, and I make it. Cool. So that's ready to run. If I go over to Arduino and go to that one, I'm actually going to add something after the if, but in the loop. I'm going to do a serial.println, and I'm going to write hello. And specifically, I did the print line because that's going to send the new line character, and it's going to send the entire string as a package deal and not a byte at a time, as opposed to if you did serial.write, which I think many of you are probably familiar with. This guy also can take a string, but it's going to send it over, I believe, a byte at a time, and the new line will not be there. So sometimes it can, unless you manually add it. And I tried that, and it actually seemed to freak out a little bit on the serial library. The response kind of came in staggered. So sometimes you get halfway through the word, or you get the full word, or sometimes you get a single character and then it read again. So stuff was a little weird there. One thing you do need to have, though, is you need to put a delay here. Just give it enough time between writes for the C++ to read it out fully. I put half a second in here, and that seemed to be enough. If I go ahead and upload this, and then we jump back to the terminal, what we can do is we can just run this guy. I'll make it, and then just right here. And we should receive port opened, and then the word hello. Let me run it one more time, just make sure. Boom, hello. And so it's very critical to have that time, just to make sure that this has enough time to read, that delay right there. I use the print line. It seems to make it super straightforward. It's very easy. This lets you send over the full string that you can then do string comparison on the receiving side and say, okay, rather than have to do a lot of these tutorials that tell you for communication, oh, send a byte, so you'd send a B, and that means go backwards. Here you can literally have the word back, and if you parse out that string, you can then match it with whatever you want to do on the C++ side, which I think is pretty neat. Okay. Now let's look at the CMake list, which is kind of the last tie-in point to build this library into a C++ project. So we go to the CMake list. It's a very standard CMake list, very just boilerplate with a little bit of extra stuff. So you've got the CMake minimum required version. I usually set this to at least 3.5. And then I just name the project. So we're going to call it Arduino Communications. That's going to dictate what the actual executable is called at the end. So if you want to name that something cool, go for that, do it. We're going to just have include languages and CXX. Then we're going to allow for include current directory. We're going to let it look for files in the current directory. We also set the standard to 11. You want to at least set it to 11. A lot of the times I'll even set to 17, as that's becoming more and more prevalent. There's not a lot I still want to be supporting in 11, but this doesn't hurt to, unless you got something specific, to have that kind of backwards compatibility. It says standard required on, that's just some boilerplate stuff. And then, actually, I have a redundancy in there. That's unnecessary. That is on line 5 as well. And then what we do is we say, okay, we want to include directories, that we want to have the include folders that we can look into. So we've got the third-party one, and then in there is just include. So I'm going to throw that into this line right here, so in third-party / include. And then what we do is we set the source environment variable, set serial source environment variable to be the third-party source serial.cc. We also include the serial.h. Third-party include serial v8 student, and the impl list ports Linux. So once again, you've got the serial.cc, serial.h, the v8 student h, and then the Linux ports cc. If you're using Windows or Mac OS, I believe there's different ones inside of there. Let's just look right now. If we go into, it's the source, impl, Linux list ports. Yeah, so there's OS X, and then Win. Specifically, I'm using Ubuntu, so we did the ports Linux. And then what we're going to do is we're just going to append the third-party source impl Unix DC onto that guy as well to include. So right here is basically just including the package of everything into the serial library, and specifically this actually comes from a answer to a closed bug report on the Woodward serial GitHub library. So this specific CMake basically is pulled straight from that code that they wrote up as a response to someone asking how to include this in CMake. So a lot of this is not me specifically. Then we add the library because we're creating it as a library named serial. Then we're going to target link the library, do the RT additional parameter there. Then we're going to add, just generate the executable. This is some standard CMake stuff. Make sure this name right here, the Arduino communication, matches the project name, or it'll yell at you. And then we have our own personal file, which is the test CPP that I was showing you guys right here. And then what we do is we target link the library, the serial library, to that communication. So the Arduino communication executable knows where to look for things like the write and read and the my serial port. So yeah, it's pretty standard stuff, nothing crazy. A lot of this comes from the actual GitHub, like I said. And yeah, that's pretty much all you need. So yeah, so that's the full tutorial. That's the example. There's nothing really too much to it. Obviously, it gets more complicated as you add more functionality to that. One of the applications for this would be in robotics between the Raspberry Pi, C++. I've done that before. Or you could have it as a external piece for a computer. So say your computer is running voice detection, which is a tutorial I'm thinking about doing in a little bit. If you had it so that triggered on keywords, it would send a serial to the Arduino. That Arduino is usually the functionality bridge between your computer and, say, controlling your lights. Or maybe it throws a relay to turn on your coffee pot, stuff like that. So those are all the applications that you could branch this off to, and basically you're looking at 20 to 30 lines of code. So it's pretty exciting. If you found this useful, or if you have comments, please comment below. If you liked it, please put a like, thumbs up, and then consider subscribing. That's always awesome, and it motivates me to keep doing videos, which hopefully keep getting better. So thank you so much. Have a great rest of your day.